Hello and welcome to episode 6 of the Biology of Superheroes podcast. I'm your host, Dr. Shane Campbell-Staton. We're back from a bit of a hiatus with this episode. There have been a few big changes here in the lab over the last few months, not the least of which is that we have moved. So recently, I finished up my fellowship with the National Science Foundation, and I just started as an assistant professor of biology at the University of California in Los Angeles. I'm really excited to be here at UCLA. As some of you know, my co-host Arian Darby has lived here in LA for a while now, so we're super excited to team up in person and bring you the latest and greatest in science and science fiction. We're going to be like the West Coast Avengers out here. I'm just super stoked. So this episode has been a long time coming. Today we're going to continue our conversation about the classic movie series Jurassic Park. So back in episode 4, we talked with Dr. Beth Shapiro about cloning and ancient DNA, resurrecting ancient species. And in this episode, we sit down with a good friend of mine, Dr. Evan Kingsley, to talk about dinosaur sounds. So Evan is a developmental biologist and a postdoctoral fellow at the Harvard Medical School, and he spends his days studying the development of a very special vocal organ in birds, the syrinx, S-Y-R-I-N-X, the syrinx. Now, I have to admit, throughout this episode, from time to time, I refer to this organ as the spherynx. I have no idea why I want to pronounce it that way, but I do, and it slips out that way from time to time, but it's the syrinx. So we talk about what dinosaurs may have sounded like and how we learn about aspects of ancient life that don't get left behind in the fossil record. So sit back, grab a snack, and enjoy, because the Biology of Superheroes podcast starts now. So in this episode, we're going to continue our conversation about the epic series Jurassic Park. The last episode we talked about Jurassic Park was episode 4. We sat down with Dr. Beth Shapiro and we talked about the biology of de-extinction, bringing back ancient organisms, cloning, getting ancient DNA. We went through a lot of really awesome science in that episode. So a lot of our conversation in that episode revolved around the original Jurassic Park, the very first movie. But obviously, there were several movies after that. Aaron, did you actually see the all of the follow-up movies after the first movie?
Yeah. Oh, yeah. Totally. Definitely followed up with the second one. They're all kind of like distinguished by moments, I guess. So Jurassic Park 2 was T-Rex in the city, right? Like I like to kind of think of it as like Sex in the City, except like T-Rex in the city. Like he kind of visited the mainland. Yeah. Jurassic Park 3 was cell phone Rex, but it wasn't a T-Rex. It was like what was the name?
It was
dinosaur was crazy.
It was a Spinosaurus. I think it was a Spinosaurus.
Maybe it was the Spinosaurus. Yeah, I don't know. I call it the cell phone dino, because he like swallowed the guy's satellite phone at the beginning of the film or whatever. Well, he swallowed the guy who had the phone.
And then throughout the movie, they like just keep playing like that jingle, like.
We're like, oh God, who knew we'd get reception out here? And it's like, and somebody's like,
where's the phone, guys?
Phone? Like, whose phone is that? And somebody's like, oh, the only person who had a phone is, oh God. He's the stomach of a dinosaur. It's a dinosaur, and then they all freak out. So yeah, that one was interesting. That whole movie was full of bad judgment.
Yeah, just bad decisions all around.
Yeah, even in the world of Jurassic Park, but also probably ties in best to our guest today. In terms of kind of some of the stuff that's going on with the conversations and communication ability with velociraptors. And then, of course, I think we both saw Jurassic World with Chris Pratt.
Yeah, of course. What'd you think of Jurassic World?
I thought it was a cool reboot. After talking to Dr. Beth Shapiro, it just twists the knife a little bit, right? Because they are now taking it way beyond what the science says is already not possible currently,
Yeah.
to, hey, we have this park, it's been up and running for years, and we're doing brand deals, and, everybody gets a T-Rex.
Yeah.
If you,
Nike presents.
Yeah, they've got like domesticated little triceratops for the kids that you can ride around on, and
Yeah.
like the Shamu section for that like big whale dinosaur that like comes up and eats like a great shark, like it's a little snack.
Yeah, the Mosasaurus, I think.
Yeah, the Mosasaurus. So it was cool, and then like everybody's new favorite pet is the Velociraptor. So that we have this interesting like domestic kind of treatment of dinosaurs, where everybody's like, yeah, cool, like I want a pet Velociraptor now, like I want a relationship like Blue and Chris Pratt.
Yeah, so I feel like our last episode on Jurassic Park kind of scarred you for life. I feel like every time I see you now, since we recorded that, your eyes have kind of glassed over a little bit.
Does Evan know the truth about the park and how not real it is?
Yeah, I think he's well aware.
He's well aware.
Yeah.
Just happy with his fossils. That's all I'm getting at, and his communication like theory in terms of restructuring, because that's as close as we're going to get. Computer modeling.
So I recently sat down with a good friend of mine, Dr. Evan Kingsley, who's a developmental biologist, and he's also a postdoctoral fellow at Harvard Medical School. And he has some pretty fond memories of this Jurassic Park series, and parts of the movie series specifically actually remind me a lot of his current work. So let's hear a little bit about his history with Jurassic Park.
I don't know, when that movie came out, I felt like that was a big deal to me.
Yeah.
I mean, I think at that point, any of us who were dinosaur kids, who were really into dinosaurs when they were younger, probably had been to a museum or some kind of place where they had recreated a dinosaur in its full, in some kind of representation of its full flesh, like where they showed you not just what the bones looked like as fossils reconstructed and articulated, but also what maybe some interpretation of what the dinosaur itself might have looked like with skin and muscle and everything on top.
Yeah.
And in some cases, I definitely remember seeing, probably not in person, but maybe on television or something, an animatronic dinosaur, kind of a motorized, like clunky kind of dinosaur that was moving from left. Its head was moving from left. Some apatosaurus or something. Its head moving from left to right really slowly. It opens up its jaws like, "Rrr,
Yeah.
rrr,
Yeah,
rrr."
exactly.
And I mean, even then, I think that I remember thinking, oh, this is really cheesy, but also totally amazing.
Yeah,
And then,
I mean, as a
then
6-year-old, like, what else do you want to see?
nothing else, literally. And then then you see Jurassic Park on TV or on the big screen, which I definitely did, and it was amazing. And these dinosaurs were, it's almost like seeing them in real life. It was really cool.
Yeah, you kind of have a longer history with Jurassic Park, though, because you actually read the books before the movie.
I did. So when the book came out in 1990, I think, I was 8 years old, and I remember my dad, who was going on trips for work, and so he would always bring home these kind of bestsellers from the airport, because he would go to the airport, he'd be flying somewhere, and he would just buy a book in the airport bookstore, and so he was buying all these kind of pulpy like Michael Crichton and who's the guy who wrote The Client? John Grisham, like John Grisham novels, things like this, things that eventually got turned into movies. But I remember him sitting on the couch reading Jurassic Park. I think probably after he got back from one of these trips, he hadn't finished it yet. And I remember seeing the cover, which was like the best, an amazing cover. It's just that profile of the T-Rex, the T-Rex skull.
Yeah, the articulated skull.
The articulated, fossil, like skeleton of the T-Rex.
Yeah.
You can just looking at it from the side on the white background, and I remember seeing that and as a dinosaur kid, really wanting to know, what is this book about? I gotta know. And I remember him just saying something vague like, "Oh, it's about this place where they bring dinosaurs back to life." Are you kidding me? Dinosaurs back to life? I gotta read this book. But of course I was like 8, right? And the book, and I read it, I think when I was probably about 10, so maybe a year or two, maybe about a year before the the movie came out.
Yeah, it's not exactly like made for kids though.
No. I think this was the first book I read that had swear words in it, which I was astounded by. I can tell you right now. But then also, it was also there are also graphic depictions of like there's maybe this is not ruining anything. I think everybody's probably seen this movie, but there's the character Dennis Nedry, who's like the kind of computer guy, who I think is he's played by the guy who plays Newman on Seinfeld.
Yeah,
Wayne Knight.
Yeah.
In the movie, and he is eaten by these, I think, Dilophosaurs, and it's same in the book. But in the book, there was a graphic description of him holding his own intestines as the Dilophosaurs eviscerate him. And I remember being extremely affected by this, just thinking this was absolutely horrifying. I mean, because I think I was like 11 years old, right?
Yeah.
But he had a huge impression on me, and it was, I mean, definitely. I remember thinking it was really, really, it was really interesting, and it definitely was. I think as a kid, it's hard to say to what degree the Jurassic Park, the book and movie, influenced my decision to become a scientist. But it is kind of cool now that we're studying in our lab. You know, we're studying living dinosaurs, birds, but also, you know, using those living dinosaurs to try to infer things about extinct dinosaurs. It is cool that it's kind of coming full circle from my 10-year-old self to my however old I am now. So
yeah, that's amazing, man.
Yeah, so I mean, it sounds like Evan maybe has just a few years on us, but a similar sense of wonder and awe and respect for all things dinosaur and just what Jurassic Park brought to the scene. You know, you got to imagine that, like, this movie and the book as well probably single-handedly reignited an interest in the field of like paleontology.
Yeah.
And all things like dinosaur science related. Like, I was not even like a kid that was that deep into things like that, but I even kind of got like a little fossil kit and like some sort of like a little model set with dinosaurs, and I was painting sculptures and stuff, and just doing all these things with you know, the dinosaurs that came out of the movie, because you were just so transfixed and just kind of inspired by seeing them come to life for the first time. And I think that's what the film series really did.
Yeah, so I think even now, right, I remember reading this report. You know, nowadays, you know, I think science can be, you know, somewhat politicized and can be, you know, a lot of areas like evolutionary biology, for instance, you know, which I do, you know, can be somewhat contentious, you know, like science versus religion. And, you know, I think a lot of studies show that, you know, there's this sort of left-right divide about, you know, a lot of different aspects of science, except one subject, and that is dinosaurs. Like, everyone universally loves and wants to learn about dinosaurs. And I would not be surprised if Jurassic Park played a huge role in, you know, that resurgence and like continuation of interest in dinosaurs. Yeah, so one of the things that you know, that Evan brought up that really interested me was this idea of using living species to learn about extinct species, right? So, you know, when we think about extinct species, you know, we think about paleontology, we think about the bones, you know, as well we should, because that is what mostly fossilizes, right? Those are the hard parts that get left behind. But, you know, movies like Jurassic Park get us wondering, you know, a lot of the time about other aspects of biology of these extinct species that don't get left behind in the fossil record, right? So things like how animals actually walked around, or how they communicated, you know, how they function physiologically. Were dinosaurs warm-blooded or were they cold-blooded? What did they sound like? Right, all these questions, you know, are really, really hard to answer based on bones. They're essentially impossible to answer just based on bones. So that brings up this question of, you know, how can we learn more about the biology of these extinct creatures? And one way to go about that is to use living species to learn about ancient species. And there's two major ways that we can go about doing that. One is through the field of phylogenetics, right, which is basically looking at the relationships amongst living species, what we call extant species, and then using that tree of life, right, what we call a phylogeny, a phylogenetic tree, using that tree of life as a puzzle, right? And then we treat some of these ancient branches as puzzle pieces that are missing, right? But by filling in around those missing lineages, we can gain information about how an organism, may have moved, or, how they may have looked, whether or not, they had specific types of coloration, what they may have sounded like, etc. And the other way of doing this is through evolutionary developmental biology, or Evo-Devo. Evo-Devo is a field that merges studies of evolution with developmental biology to try to understand the mechanisms that produce the patterns that we see across the tree of life, right? And so then we can use this idea of Evo-Devo to then, again, not only fill in those gaps of how ancient species may have functioned, right, but also try to identify the mechanisms by which those changes have occurred. All right, so in Evo-Devo, they have this saying that is probably one of my favorite sayings in all of evolutionary biology. And that saying is that ontogeny recapitulates phylogeny. Now, basically what that means is that the developmental progression of an organism essentially mimics its phylogenetic history. If you take humans, for instance, there's a point right before we're born where humans have lanugo, or what we call lanugo, which is essentially full body hair, like our closest primate relatives. If we go a little bit earlier in development, there's a point at which we develop a tail, right, like our sort of slightly more distantly related simian relatives. And if we go even farther back, there's a point in time where we develop gills, like our fish relatives. And so our developmental history mimics our evolutionary history, right? And that's what we mean when we say ontogeny recapitulates phylogeny. So Evan and his colleagues are using these basic principles to understand how birds vocalize, and we know that birds are the modern descendants of dinosaurs, and they're also trying to understand how more ancient lineages of birds vocalized. So one of the things that he told me about is the evolution of this specialized vocal organ that only birds have, called the spherynx. So we use a larynx, our sort of voice box, to communicate, but birds have a different organ that they use to communicate, and this is what he and his colleagues have been studying. So Evan told me about his work studying this organ in birds and what it might tell us about the lives of dinosaurs. I was wondering if you could talk a little bit about the sort of methods that scientists are using to draw conclusions about ancient animals from modern biodiversity.
Yeah, well, I would say the first thing that we can use, and this is the kind of the approach that we're taking, is to use the only remaining dinosaurs that we have access to that are still alive, i.e. birds, and try to understand how their vocal system works, the way that the shape of the vocal organ in different birds determines what sounds they can make. Mm-hmm. Right? So if you go out in the wild, you look at a bunch of different bird species, their syrinx, the organ they use to make sounds, is shaped in all sorts of different ways in different species. So a crow's syrinx is totally different from, it looks really, really different from, say, like, an ostrich's syrinx.
And that different shape gives a different sort of vocalization properties?
Right. So this is the thing, is we know that they sing different songs. An ostrich that doesn't even really sing a song. An ostrich makes a weird croaky sound.
Yeah. Can you tell me what does the ostrich sound like?
No, I can't.
Okay. I was hoping you'd give it a shot just for entertainment's sake.
No, I know. The thing is that like, I mean, ostriches make, I don't know, they make all sorts of, I feel like,
I actually have no idea what an ostrich sounds like.
They make a bunch of different sounds. Ostriches do make a closed mouth vocalization.
Okay.
So they actually inflate part of their throat, and they make a sound.
I got you to make the sound.
I know you did.
I
That's the problem. But yeah, they make wild sounds like that. But they have a syrinx. It's shaped differently from, say, a crow's syrinx or from a parrot's syrinx.
So, and what about alligators? So for those who don't know, so alligators are actually alligators and all of the crocodilians are more closely related to birds than they are to other reptiles. So they're more closely related to birds than they are to like lizards or snakes or any of the other reptiles. And crocodilians actually also have a really wide range of vocalizations. For those who might be interested, I think one of the coolest vocalizations is actually made by males of several different crocodilian species. It's a very deep bellow, and it's actually so deep. Huh?
Do you want to do it?
Well, oh man, I don't think the thing is I can't do it because it's so deep, right? And it's so deep that it makes it actually makes the water so they make these vocalizations in the water, and it's so deep that it actually makes the water dance on their backs. It like ripples up and down. It's really beautiful. I'm sure you could Google it and find some great images. But crocodilians, they're not birds, and so I'm assuming they also don't have this specialized organ.
They do not. They use a laryngeal sound source, so that they have vocal folds in their larynx, just like we do.
Okay, so they make their sounds the same way that we speak.
They make sounds more. Yeah, the way they make sounds is much more similar to us than it is to birds.
Okay, even though they're more closely related to birds.
Exactly right.
That's
so
fascinating.
What this tells us is that sometime between the common ancestor of birds and crocodilians, and the common ancestor of birds, this is many millions of years, of course.
Mm-hmm.
But the common ancestor of all birds had a syrinx-based sound source. The common ancestor of birds and crocodilians presumably did not. So
and dinosaurs are somewhere in between there.
And dinosaurs are somewhere in between. So somewhere in between, that's all we know right now is that somewhere in between they shifted from making a sound with their larynx to making a sound with this totally new organ, the syrinx, that doesn't exist in any other living animal. So when did it happen? We don't know, but it's certainly plausible that it happened sometime. It definitely happened sometime during the evolution of dinosaurs, and we just don't know when.
Okay. Yeah, so obviously, as you can see, the work of Evan and his colleagues on this specialized vocal organ got me thinking a lot about the Jurassic Park series. And so much so that I actually did a little bit of research about how they made the sounds from Jurassic Park, right? So, I mean, if we don't know what a dinosaur sounded like where did they come up with all these really cool, epic sounds that the dinosaurs actually made? And the answer is actually really kind of hilarious. So essentially, they did a bunch of unique mashups of, different animals to create, each dinosaur species sound in the movie. Like for instance, the raptors. They made like some combination of goose sounds and like mating tortoise sounds, to get the vocalizations of the raptors. The Dilophosaurus, which I'm sure people remember like the spitting dinosaur from the first movie. Is a combination of a rattlesnake and a hawk. And the T-Rex is part of the T-Rex vocalizations is actually based on a baby elephant, which is kind of crazy. So I thought that was really interesting. But this idea of like understanding vocalizations of ancient species got me specifically thinking about Jurassic Park 3. A big part of that story revolves around Velociraptor vocalizations, right? So in the beginning of the movie, Dr. Grant is sitting down with Dr. Ellie Sadler, and they're reminiscing about the vocalizations that they heard throughout the events of the first movie. And at this point, he's become somewhat obsessed with their communication, it seems like.
So what are you working on now?
Raptors, mostly.
My favorite.
Do you remember the sounds they made?
I try not to.
Ellie, all our theories about raptor intelligence, what they were capable of, we weren't even close.
Tell me.
Well, we did cranial scans of a fossil skull. We found what looks like a very sophisticated resonating chamber.
Wait a second. So we were right. I mean, they had the ability to vocalize.
I'm convinced it's the key to their social intelligence.
Which explains why they could work together as a team.
And coordinate their attacks so their prey wouldn't know what was going on.
They could talk to each other.
To a degree we never imagined. Ellie, they were smart. They were smarter than dolphins or whales. They were smarter than primates.
Yeah, and then later in the movie, he has this. It's unclear whether or not Billy Brennan is a graduate student or an associate professor or a research assistant, but this underling of his, Billy Brennan, 3D prints a vocal chamber, and they use it to recreate raptor calls. Right? And this got me wondering a lot about how realistic this is.
Yeah, one of the things I found interesting about movies 1 and 3 was just the amount of science involved. And you can tell that in Jurassic Park 3, when Dr. Grant is over at Dr. Sadler's house, he's almost on the verge of a new breakthrough, it seems like, in terms of communications, like you just mentioned. And, they're talking about raptors and their resonating chamber and the fossil skull and this ability to kind of vocalize and work together as a team when they're out there as a pack. Just speaks to the fact of how highly intelligent they were. And I think even in the film, they're described as being smarter than dolphins, whales, and even potentially primates. So you have this really ferocious creature that's highly intelligent and socially sophisticated, and essentially equipped with what had to be an evolutionary advantage at that time. So, I think it just speaks to the longevity of just the raptor and fascination around that creature as one of the coolest dinosaurs, I think, since sort of the beginning of the Jurassic Park series, even all the way through to Jurassic World. Everyone loves raptors.
Absolutely.
As much as they are equally horrified by them, but they are by far everyone's favorite dinosaur because they're just so cool. I think life imitates art in a lot of ways, where as the fascination with raptors has grown, I'm sure a lot of the science around studying them has evolved and pointed to new and exciting sort of discoveries about them, which is in turn fed back into that fascination. So, that's pretty cool.
Yeah. So
another thing I'd want to point out as well is that Jurassic Park, even technologically in terms of what they're talking about in the films, was seemingly ahead of its time for the audience. Like, this movie featured 3D printing back in 2001.
Yeah, that's just crazy.
I think people are barely starting to wrap their heads around the existence of 3D printing now. Like, it's catching on, maybe in some hobby enthusiast circles where people have their own 3D printers at home and they're doing stuff. And obviously in the scientific community, it's making big headway. But it's still not like a mainstream thing. Like, not everybody has a 3D printer at home and they're not just cranking out random things to replace around the house and so on and so forth. So back in 2001, I can't quite even recall how I felt about it. But when I probably saw it, I don't even know if that struck me as something that was believably happening, or if that was movie magic. Like, the line was a lot thinner there, where I just wasn't even quite sure what was going on, but I kind of accepted it with the narrative of what was happening. I'm like, sure, okay, he just made a dinosaur kazoo out of a machine. That's great.
So I think you definitely bring up a great point with the 3D printing, because I think at the time that Jurassic Park 3 came out, I think that was still pretty science fiction-y, right? The idea of not only having a 3D printer, but taking it out into the field, right? It wasn't like they were in a lab somewhere. They basically, went straight into the ground and 3D printed, the chamber of a fossil like in the ground, which is pretty crazy. But since that time, now 3D printers, a lot of people in that study functional morphology, that study paleontology, that study developmental biology are using 3D printing on a pretty regular basis. And I asked Evan a little bit more about this velociraptor chamber, this like vocalization chamber that we see in the movie and how it lines up with what we know about dinosaur communication.
Yeah, so it's unclear exactly how those velociraptors in the movie are vocalizing. So when I say vocalizing, I mean where their vibratory tissue is, right? So like ours is in our larynx, in our necks near our mouths, whereas birds have it much farther down in their chests, in the syrinx, and it's not clear where the actual vibration is happening, right? So that part is the movie doesn't discuss at all. They are producing this. I think Billy, the graduate student, or Billy, the whatever he is, calls it a resonating chamber, I think, or something. And so this is the thing that I don't. As far as I know, I'm not a paleontologist, but as far as I know, there's no evidence that velociraptors or any other theropod dinosaur had this kind of resonating chamber in their skulls. So my sense is that is based on in the movie they show an image of a velociraptor, a kind of profile of a velociraptor skull, and they show this inside of it this resonating chamber, a representation of this resonating chamber, and that's the thing that he prints. And so the idea there probably is that there's a vibration that happens somewhere either in the larynx or in the syrinx, but it's unclear where. That sound ends up traveling through some airway passages, nasal passages or something, in the skull, which in this fictional representation, it allows some additional resonation of the sound, so that the sound is actually resonating inside the skull, allowing it to have some different quality than it would just be produced from the vibration alone. Does that make sense?
To like something to be louder or to travel farther.
Yeah, I mean it's in the same way. Like, okay, think about if you're blowing across the top of a bottle, right? You're causing this. You're using this resonating chamber, the bottle, to make an additional sound that wasn't there when the air came out of your mouth. Right?
Yes.
So it's kind of like I think that's a sort of a similar idea to what I think is what they are proposing in Jurassic Park 3 might be happening with these dinosaurs. And I should say that this has been proposed in the scientific literature for I guess they're for lambeosaurs, these specific type of lambeosaurs called hadrosaurs, that have these huge crests on their head, these big like kind of their skulls have these really tall, they're not horns, but they're basically part of their skull that kind of extends back off the top of their heads.
We actually see these in Jurassic Park, right?
Yeah, absolutely.
They're sort of one of the sort of flocking species that and it kind of have like a duck bill.
Yeah, that's right. Yeah. Hadrosaurs they kind of have a duck bill, and they have these really big crests, and part of one of the hypotheses for why these crests exist is that they are actually used as resonating chambers. The crests actually contain some part of the nasal passage, and that the nasal cavity, and so they actually may be acting as a resonating chamber in the skulls of these hadrosaurs. Now, it's a little bit of a stretch to suggest that these resonating chambers existed in other dinosaurs, where there's no evidence that the nasal passages are,
Yeah, they have this very extremely specialized morphology.
yeah, the morphology of the Velociraptor nasal passages, as far as I know, like I said, caveat, not a paleontologist.
Yeah.
But I'm not aware of any literature that suggests that there are resonating chambers in the Velociraptor skull. And I should say also in the movie, right? They actually, when Billy at the beginning of the movie and at the end of the movie, Dr. Grant blows through this resonating chamber with their lips, right? And it seems like they're kind of playing it like a trumpet or something, right? Like they're kind of pursing their lips and vibrating their lips against it, like a trumpet mouthpiece. It seems unlikely to me that would produce the same sound as, let's say, a larynx would produce if it was at the bottom of, the larynx is vibrating a column of air between the larynx and this resonating chamber in the skull.
Okay.
Hypothetical resonating chamber in the skull. That would make a different sound from if you put the vibratory tissue right against the resonating chamber, right? So this would be like, this is like blowing through a trumpet to make a trumpet-like sound versus trying to put your lips, like on the other end of the trumpet, basically. Like, you know what I mean? Like the vibratory tissue has to be at the right spot for it to make the same sound.
So it's the whole system, that sort of works together. Everything from the lungs through the bronchi, like the distance between the lungs and this hypothetical resonating chamber. All that stuff works together as a system to produce a very specific sound. So if you take out one piece and then you just try to run wind, just like try to blow through it, you get something completely different. So essentially what you're saying is that they would have when he tried that, the Velociraptors would not have been confused at all, and it would have just eaten the whole crew, is what you're saying.
I mean, it's hard to prove that would have happened, but
it's a working hypothesis. So given what Evan said, it seems like this vocalization chamber that we see in the movie, this Raptor vocalization chamber, is pretty cool, but it seems to be pure fiction, more or less. Right? So as far as we know, at least, they took a little bit of artistic license there.
Yeah, I mean, it seems like it's much less of a resonating chamber, and also much less of a kazoo and maybe more of a trumpet. I'm not sure which instrument we're referencing here, but I think in lieu of taking the time to really get into the science and keeping the movie moving along, I get why certain decisions were made, but it's interesting to dig into the science a little bit more and sort of hear the specifics of what actually may have occurred back in sort of an evolutionary perspective with raptors. But it also sounds like the jury's still out, and we're kind of still figuring out what the answer is.
Yeah, absolutely. And, but even given that, right, this idea that you could potentially take an ancient organ, right, and build a model of it like we see in the movie, and then pass air through that model and try to understand communication that has not been heard in millions of years really, really intrigues me. And it turns out that this is pretty much exactly what Evan's colleagues are doing to gain a clearer insight into the sounds that were produced by ancient birds. So let's hear what he had to say about that. So we sort of have, the layout for sort of our understanding in this field of sort of dinosaur vocalization, which seems to still kind of be in its infancy. It seems like we still don't know a whole lot about it. And, but while we're talking about communication, if I'm not mistaken, there is someone who's trying to use this sort of dinosaur version, or there's like older, like more ancient versions of the Sphinx, and actually like making like active models of these things and like running air through them. Is that correct?
For sure. Yeah. So we, our group that studies we studied the development, that like kind of how these structures form in the embryo of modern birds. But we are collaborating with paleontologists and also these really, really talented and smart vocal physiologists. So these people one of their main things is try to understand how birds make the sound that they make, like the physics of actually, these vocal flaps that are vibrating against each other, how that changes the airflow, and how the vibrations of those things actually produce a sound, physically, which is a very complicated physics problem. The fluid dynamics of airflow through a complicated structure is not simple.
Yeah, it's
and so these people are
physics.
Absolutely. No, and this involves lots of computational, very powerful computational methods where they're simulating how this airflow works and how the different strains of the airflow affect the shapes of the airways. Anyway, it's all very complicated. But the thing is that their whole reason for their whole study the whole kind of background of what they study is all about how sound production works, and different parts of the group study it in birds or in humans or in but now they're starting to get into, in collaboration with us and our paleontologist friends, they're starting to get into these ancient bird morphologies and trying to understand, if we can understand how those ancient bird morphologies might have generated sound and what they might have sounded like. Mm-hmm. So the first step to doing that is generating a physical model of a syrinx, and we can use modern morphologies, modern shapes of bird syrinxes.
Uh-huh. Do they get 3D printed like they do in Jurassic Park 3?
Well, I'll tell you what. We have a 3D printed model of this fossil syrinx, the ancient syrinx that I was telling you about before, the one that they got from the CT scan.
Yeah.
We have a 3D printed version of the cartilage. It's pretty cool, actually.
Have you tried to blow into it to see what kind of sound it made?
I have to say I haven't. Partly because it turns out, right, the thing that, it was hard enough to find the fossil cartilage.
Uh-huh.
But the thing we really don't know is what the soft tissue, what the actual vocal folds looked like, and what their shape was. And that probably also has a huge, we know actually that has a huge influence on what the sound sounded like. So we're part of the way there, but we still don't know what those soft tissues look like.
So we've learned a lot about the vocalizations of modern birds, and we're beginning to gain an understanding of the vocalizations in ancient birds. But this field of what I'll call PaleoBioacoustics is still in its infancy, and we still know pretty much nothing about the sounds of true non-avian dinosaurs. So I asked Evan what we would need to do to make that jump in our understanding and actually figure out what dinosaurs sounded like. Do you think we'll ever get to a point where we actually have a working understanding or like a realistic representation of what a velociraptor or a tyrannosaurus or a hadrosaur actually sounded like?
I mean, it would require finding a fossil of a non-bird dinosaur syrinx or larynx or anything like that.
So we haven't found this yet?
We haven't found it yet.
Okay.
And I think if we found a non-avian, a non-bird theropod dinosaur, say T-Rex or something that had we found it would have to be very, very well preserved. But let's say we found that very, very well preserved fossil, and in that fossil there were the cartilages of the airway preserved in there, and we could CT scan the whole thing and find it. That would be a step towards understanding. If we could see there that it had this syrinx-like structure, that would be a step towards understanding the vocalization of non-bird dinosaurs, and it would suggest that they're much, again, much more like modern birds than was traditionally thought. And this is a thing that, in the last 15 or 20 years, people have really started to learn that a lot of non-bird dinosaurs had what looked like feathers, or right, and things that people didn't realize probably evolved earlier than modern birds, and were present in these very scary dinosaurs. May have also had some kind of fluffy feathers on them.
Yeah.
So we've only learned that fairly recently, and so who knows? Maybe they were more like modern birds in other ways too.
So it seems like basically a lot of this will depend on luck. All right. So, in order for us to really understand, what these organs, like what these vocalization organs look like in dinosaurs, we would have to find a very well-preserved specimen and then make a model based on that specimen to just begin to understand, what they may have sounded like. Yeah. And this may seem a bit far-fetched, but, like Evan said, we've been getting pretty lucky recently with some amazing findings about dinosaurs, that have really sort of changed the way that we understand the way that dinosaurs work. And even since, the first Jurassic Park movie came out, we've learned that, dinosaurs may have looked very different than than they're depicted in that movie. For instance, they may have all had feathers. There's a lot of evidence now that many dinosaur species, including theropod dinosaurs, like velociraptors and maybe even T-Rex, had basic feathers.
Yeah, a couple things here. The idea about luck and sort of over time stumbling upon or coming across the evidence that you need to take the next scientific step forward. I read somewhere even in the original Jurassic Park film, Steven Spielberg wanted velociraptors to be about 10 feet tall, but at the time, the science didn't support that assertion that they could reach that height. However, during production, they actually discovered a raptor in Utah, I imagine, because it ended up being named the Utah Raptor, I believe.
Oh.
That was actually 10 feet tall and sort of fell into the range that Spielberg his raptors at. So that's pretty cool. The second thing is the idea about how these dinosaurs are, more and more increasingly becoming and appearing to be a lot more related to birds and then maybe the reptilian side of the spectrum in terms of their appearance and some of their feature sets. And, in the first film, Dr. Grant, is actually kind of taking a look at an image of a raptor. And this kind of goes back again to sort of how Jurassic Park has always been technologically ahead of its time. They had this little machine in the first film where they were basically able to discharge a pulse into the ground, and then that pulse emanated a wave which essentially bounced off of the bones in the ground and sent back an image, I guess kind of like a radar detection type thing.
Some sort of fancy sonar or something like that.
Yeah, some sort of a sonar sort of bouncing technology, and essentially up on the computer screen imaged the entire structure of a raptor. And he was looking at it and he was talking about the bone structure and saying how some of it matched what you'd find in modern day birds, to the point that he kind of commented offhand that he was surprised that, or he wouldn't be surprised rather, to hear that or find out that those animals didn't just take off and fly. It seems so much similar to that he could hypothesize and imagine they weren't too evolutionarily far away from that ability. And then I think what most people remember from that scene is the young kid coming in saying, "Well, it looks like a giant turkey to me," and then Dr. Grant like takes out his claw and like pretends to kill him and talks about you holding your intestines and like watching yourself die as they eat you because you'd be very much alive. And so he said to have a little bit more respect for these animals. And how about that for a giant turkey for you? So I think that's interesting that the science is kind of confirming that, and these animals could have very well been covered in bird feathers and so on and so forth. But I think the main thing I'm getting at, and that I'd like to see, despite all the warnings, Dr. Grant said some of the worst things have been done with the best intentions, but I don't care. I want to see Jurassic Park come to life. Like, I want the park.
Yeah.
For real. There are two things that are on my bucket list, and I think people, set up their bucket list and they want to say, achievable stuff like, I want to go to Italy, and, I want to scuba dive in the Great Barrier Reef. But I want to go to space, and I want Jurassic Park. Those are the two things I want to see in my lifetime. I get the warnings. I don't care. Like, I watched Apollo 13 blow up. I've seen all the Jurassic Parks. Like, someone fat is going to get spat on. Someone in the bathroom's privacy is going to get interrupted. Like, someone black is going to die. But I don't care. Sign me up. Yeah. Like, let's go. Because there's a lot to learn, and I want to learn it before I die.
Yeah. Okay. Fair enough, man. So I want to. So before we leave, I asked Evan a little bit about superpowers and what he thinks his would be. So let's hear what he had to say about that. One more question that I have for you.
Oh no!
If you had any superpower, what would it be and why?
Oh man, that's really hard. No, sorry. When you say any superpower,
if you could have any superpower,
so this is not like superpowers as they are the superpowers that have been described in comic books. This is any.
If you could have absolutely any superpower that your imagination could think of, what would it be,
okay.
And why? The why is an important question.
Sure, of course. So, in the spirit of our conversation, I have to say, it would be hard for me to say no to time travel.
Okay.
Because, first of all, we could learn a lot about the stuff that we're studying now. If we could just go back and look, it would be so easy.
That's true. Just go back with your notebook, maybe take a video.
That's right. I'll bring a scalpel and some forceps, and we can do some dissections. It'd be great.
But we should keep in context Jurassic Park 3, man.
I was gonna say,
when the graduate student or the assistant went and stole the eggs, it did not pan out well.
I was just gonna say that would be exactly the problem. Like I spend half of my day, almost every day, opening up the eggs of fertilized bird eggs, and that would be the way to study it. You want to get your hands on some of those fertilized dinosaur eggs. But I would not want to be chased by velociraptors. I'll tell you that.
Yeah. No matter what they sounded like.
That's right. Exactly. That would be. So the why is certainly one of the reasons why would be definitely to learn a lot more about extinct organisms. We could that would in some ways it would take some of the fun out of it, but it would probably be cool enough that it'd be totally worth it.
Yeah. I'm sure you definitely get a few high impact papers out of that study. If anything, for actually creating a time machine, right?
Well, right, sure. Yeah, time travel reveals insights about would be the way that my papers start.
Yeah, but it also suggests that you've learned absolutely nothing from any of the time traveling science fiction that has ever been produced because it never turns out well.
Listen, I saw. I mean, things were fine at the end of Back to the Future Part 3, so I assume everything could be okay.
That's true.
Yeah, I mean, and on a smaller scale, that does raise questions about the temptation of going back in time within one's own life and trying to modify certain decisions that one made in the past. I'd like to think that I could resist that temptation and only use it for knowledge, knowledge gain. But
only use your powers for good.
What's so tempting?
Yeah, I know. with great power comes great responsibility, Evan.
Yeah. There you go. Didn't learn anything else from Spider-Man.
Awesome. Well, thank you so much, man, for your time.
Yeah, no, thank you. This was fantastic.
Awesome.
Really enjoyed it.
I know we didn't get too into comics into this episode, but it was great to hear Evan's choice on a superpower, if he were able to have one. And just one random fun fact that I noticed in the credits here with Jurassic World. So the character that represents the company man from Engine, sort of the the blood money company in the dinosaur creation game, who's always looking to kind of weaponize dinosaurs or kind of use them for military tactics or whatever. The guy that played that character, and I believe it was Hoskins, Vic Hoskins was his character in the movie in Jurassic. The actor is Vincent D'Onofrio, or D'Onofrio, not sure how to say it, but he also played Kingpin, Wilson Fisk, in the Daredevil series on Netflix. Just
way
like a crazy
to bring it back.
Transformation in terms of just acting ability. I had no idea until I saw the name, because I was just like, man, this guy he is an actor's actor, ladies and gentlemen.
Yeah.
That's how we tie the two worlds together.
You showed some serious dedication in getting that back to comic books just now. I was wondering where you were going with it.
Biology of superheroes. We did it again.
Done. Although some people don't know this, but Jurassic Park itself was also a comic book series. So Jurassic Park Redemption was released in 2010. Features all the classic Jurassic Park characters. So if you're interested in reading about Jurassic Park in graphic novel form, you should check out Jurassic Park Redemption. It's a 5-part series.
Awesome. Sounds like a good time.
Yeah. And also, I didn't have to go that far around to get back to comic books. I just want to point that out. Efficiency. That's where science gets you.
We'll see what the people think of. I think my fact is a bit.
Okay, fair enough. Well, as always, man, it's great to have you on.
Pleasure joining you as always, and I can't wait to talk more about this stuff in the future episode.
All right, let's do it. I'll see you back in the lab.
Sounds good, man. Take care.
Peace. I really hope you enjoyed episode 6 of the Biology of Superheroes podcast. The Jurassic Park series is one of my all-time favorite science fiction pieces, so it was a lot of fun exploring that universe, and we've got a lot more sci-fi ahead in the next month. So in celebration of Halloween, we're bringing you a very special episode of the Biology of Superheroes podcast, our first crossover event. So for the Halloween episode, we're teaming up with the brilliant ladies of This Podcast Will Kill You, Dr. Erin Welsh and Dr. Erin Allman Updike. So if you've been under a rock somewhere and you have not heard This Podcast Will Kill You yet, I strongly suggest you get into it immediately. It's all about the history and biology of diseases. So it's some of the most charming and disgusting conversation you could ever hope to hear. We're getting together to bring you a special 2-part Halloween crossover all about zombies. We'll talk about some classic zombie science fiction, including The Walking Dead and World War Z. We'll chat about epidemics and real-life zombification that happens all across the tree of life, including in humans. And if that's not enough for you, you can also check out my upcoming interview on Harvard's podcast series, Veritalk. I chat with host Anna Fisher-Pinkert about giant monsters, dystopian futures, and adaptation in a world of climate change. So we got a lot of different things happening this month, and I really hope you dig into them all and enjoy. So with that, I'll say stay tuned and stay curious.